12টি লেকচারের যে সিরিজ অন ফোরট্রান লার্নিং, তার প্রথম লেকচার ডে 1, তার অডিও ভার্সন। আমি স্লাইড নাম্বার উল্লেখ করে করে বলে যাব, ফলে ওই পাওয়ার পয়েন্ট ফাইলটি যে কেউ স্বচ্ছন্দে ফলো করতে পারবে along with the audio file. So let me start the show. Slide number 1, naturally title slide. আজকের বিষয় Preliminaries of Computer Language and Lockdown Series Day 1 of PCTF Initiative. Slide number 2, Components of a Computer. Chemistry ছাত্রের কম্পিউটারের এভরি ডিটেলস আর্কিটেকচারাল অ্যাসপেক্টস জানার নিশ্চয়ই প্রয়োজন নেই, কিন্তু মোটামুটিভাবে কম্পোনেন্টসগুলো কি সেটা আমরা দেখে নিই। প্রথমটি হচ্ছে ইনপুট ইউনিট। তারপর আমি চাইবো কিছু ইনপুট দেওয়ার পর যেটা ক্যালকুলেশন হোক। অ্যারিথমেটিক ইউনিট ইজ দ্যাট ইউনিট হোয়ার দ্য ক্যালকুলেশন ইজ বিন ডান। এবং তারপর আমি চাইবো যে আমার ডাটা, রেজাল্টস, ফাইলস, ইনফরমেশন সেগুলো স্টোর্ড হোক। সো আই নিড আ মেমোরি ইউনিট। আর এই তিনটে ইউনিট এবং তার সাথে সাথে আউটপুট ইউনিট, এই সবগুলোকে কোঅর্ডিনেট করে, যে সেতুর মতো লিঙ্ক করে, সে হচ্ছে কন্ট্রোল ইউনিট। ইট মেনটেন্স দ্য লিঙ্ক বিটুইন মেমোরি ইউনিট অ্যান্ড কন্ট্রোল ইউনিট, অ্যারিথমেটিক ইউনিট অ্যান্ড কন্ট্রোল ইউনিট, অ্যাজ ওয়েল অ্যাজ উইথ দ্য আউটপুট ইউনিট। এই মাঝের যে মেমোরি ইউনিট, কন্ট্রোল ইউনিট এবং অ্যারিথমেটিক ইউনিট, এটাকে একসাথে বলা হয় সেন্ট্রাল প্রসেসিং ইউনিট বা সিপিইউ। এই হলো মোটামুটি স্ট্রাকচার অফ এ কম্পিউটার। Slide number 3, where do you start? অর্থাৎ with reference to the structure or architecture of a computer, the user, where do you stand? It starts with hardware. Hardware expertise আমাদের সবার দরকার নেই, শক্ত। In fact, two levels are there in between you and the hardware, the difficult part of the computer hardware. One level is system software. আমি যখন মেশিনটাকে প্রথম অন করছি, বুট আপ করছি, তখন কিছুক্ষণ সময় নেয়, সেই সময় আসলে ব্যাকগ্রাউন্ডে কিছু প্রোগ্রাম রান করে এবং কম্পিউটারটা ইউজারের জন্য ইউজেবল অবস্থায় নিয়ে আসে। যে প্রোগ্রামগুলো রান করে সেগুলোকে আমরা বলি অপারেটিং সিস্টেম। ফর এক্সাম্পল, ইউনিক্স অপারেটিং সিস্টেম, ডস বা এমএস ডস, লিনাক্স, এবং আমরা যেটা ইউজ করছি এখন উইন্ডোজ, এরা সবাই অপারেটিং সিস্টেম। তারপর হচ্ছে অ্যাপ্লিকেশন সফটওয়্যার। এই যে পাওয়ার পয়েন্ট যে সফটওয়্যারটার সাহায্যে আমরা চালাচ্ছি সেটা হচ্ছে একটা অ্যাপ্লিকেশন সফটওয়্যার, বা আমরা যে ফোরট্রানের কম্পাইলারটা ব্যবহার করবো ফোর্স 2.0, এটাও একটা অ্যাপ্লিকেশন সফটওয়্যার। আমরা এটা ডাউনলোড করি সাধারণত ইন্টারনেট থেকে। এবং এইবার হচ্ছে আমি বা ইউজার, ইউজার তার মতো করে একটা ল্যাঙ্গুয়েজ ফলো করে, হাই লেভেল ল্যাঙ্গুয়েজ বলি আমরা, সেইটা অনুযায়ী প্রোগ্রামটা লেখে এবং কম্পিউটারকে রান করে। তো এই হচ্ছে মোটামুটি where you stand with reference to the computer. Fourth slide, for a chemist, Fortran and Computer, why and how really? Why do I need at all learning programming or computation, etc.? So খুব সাধারণভাবে বললে স্ট্রাকচারটা এরকম, যে সাপোজ ইউ হ্যাভ এ ফিজিক্যাল প্রবলেম. Physical means it's a real world problem, maybe physical, maybe chemical, maybe economics problem, or whatever it is, biological problem. Then what you do usually, taking help of a mathematical model, we do modeling and we translate the problem into a mathematical problem, which is a bit complex. So we need simplification, and with the help of numerical analysis, we make a simplified version, mathematical simplified programmable problem. Since it is now programmable, so I would like to write a program with the help of flowchart algorithm, which is the systematization of your logic, and then using any suitable of your choice high level language like C, like Fortran, like Python, you write a program and then you feed in to the computer, and computer with the help of a compiler it compiles. We'll see later what compiles mean. Basically, it translates the program, or we call source code, written in high level language to machine language or assembly language which the computer hardware understands. Okay, so now you run it and you get some results. You analyze the results, and if it's at par, then fine. Otherwise, you go back to your model and modify your model, and again follow the same cycle. So this is how really computer programming works in reference to your physical problem. Now, slide number 5. Often you encounter such kind of conversation between two friends that, okay, we have purchased a computer, what's the capacity? Then he or she answers, it's 2 GB 500. What does it mean? Actually wants to tell that it is of 2 GB RAM and 500 GB memory. So what is RAM? What is memory? In what unit do we measure memory? These are the questions. Before that, let me introduce the difference between RAM and ROM. RAM and ROM both are memories, of course, but of different types. RAM, the abbreviation of read random access memory, and ROM is read only memory. So what are the characteristic features? RAM is volatile, temporarily stores, that we say, and ROM is of course the opposite, non-volatile and permanent. But what does it mean? In RAM case, it saves the information in electrical transistors, whereas in ROM it is in chip or cells. When electricity is off or computer is shut down, switched off, then of course the RAM memory vanished. I mean, whatever is there in RAM memory is vanished, erased. But in case of ROM, because electricity is not necessarily related to this memory, so the memory content is not erased as soon as electricity is gone off. You can extend the RAM from 1 GB to 2 GB or 2 GB to 4 GB and so on, but the ROM usually you cannot extend. U means the user. Now, for better understanding, if you compare your computer with a library, then the library has so many bookshelves and which contains the books permanently, so they are comparable to ROM. And in a library there is a small reading room and even smaller table, only it can accommodate only few, and the table accommodate only a few books, and after the books are consulted, the books are taken back to the shelves. So this reading room library table, it can be compared with RAM. As far as you are using the books, okay, you are using the table, and then after the job is over, you just put it back to the shelf. So this kind of RAM and ROM differentiation. So next slide 6. Suppose a computer has a level 64 KB 16-bit memory. So what does it mean? So we are talking about actually the unit of memory, and that is kilobyte. 64 KB means kilobyte. So byte is of course a unit, and again 16 bit. So bit is also a unit. And since one byte is 16 bit, for example, that means bit is more fundamental than byte. As if you are using 16 letters in a word, then byte is word and 16 letters are 16 bits. Or in other words, if you have a highway and there are so many lanes, and suppose 16 lanes are there, then the lanes are bits and the highway itself is the byte. And as you know that more the lanes, that means more the bits, more the speed on the highway you have. Now the question is 64 kilobyte KB. What do you mean by kilo? Say when I say 1 kilo rice, then of course is 1000 gram rice, right? Kilogram is 1000 gram. Similarly, 1 kilobyte is 1000 byte. Is it? No. The answer is no. 64 kilobyte is not equal to 64 into 10 to the power 3 byte. Then what it is? 1 kilobyte is not 1000 byte but 2 to the power 10 byte. That means 64 kilobyte is 2 to the power 6 into 2 to the power 10, that is 2 to the power 16 byte. So 2 to the power 10 is very close to 1000, of course, but not exactly equal. In fact, 2 to the power 10 is 1024. So 1 kilobyte is 2 to the power 10 bytes. That means 1024 bytes, not 1000 bytes. So similarly, 1 megabyte is usually 10 to the power 3 kilobyte. That means 10 to the power 6 byte. Again, in case of computer, it's no. 1 megabyte is actually 2 to the power 20 byte. And similarly, 1 GB is not 10 to the power 9 byte, rather it is 2 to the power 30 byte. So kilobyte, megabyte, gigabyte are actually 2 to the power 10, 2 to the power 20 and 2 to the power 30. So the question is why 1 kilo is not 1000 but 2 to the power 10. So now question slide number 7. I propose to switch over from your attention from something serious to something casual. Solve a puzzle of the month. So it's written over there as you see, DEC 25 equals to OCT 31. So on a first glance, it's a puzzle of month. So I am deliberately pushing you towards month. That means you will try to answer that, okay, somehow December 25th is equal to October 31st, and you will never get the answer actually, because in no way December 25th is equal to October 31. No way. So what is the mystery behind this puzzle? By the way, this puzzle is taken from a very famous and popular mathematical learning and puzzles book, Mathematical Circle, a Russian experience. So let us consider number system to understand this puzzle. So in our childhood আমরা শুনেছি একক, দশক, শতক, সহস্র, ওই 1 10-এর ঘর, 100-এর ঘর, 1000-এর ঘর, এটা আমরা সবাই জানি, কিন্তু এটাকে আমরা ভাবলে দেখবো যে এই 1, 10, 100 এগুলো এইভাবেও লেখা যায়। 10 to the power 0 is 1, 10 to the power 1 is 10, 10 to the power 2 is 100 and so on. এবার যদি আমরা 2, 5 এই দুটো ডিজিট দুটো ঘরে লিখি, দশকের ঘরে 2, একের ঘরে 5, তাহলে আমরা জানি উত্তরটা আসলে 25 is 25 because 2 into 10, দশকের ঘরে 10 plus 5 into 1, so total is 25. But the question is why 10? Historically, actually, human beings when started thinking about counting, they used to count by using their 10 fingers of 2 hands. So that's why 10. But in jokingly, if I say that if government just cuts 2 thumbs from our 2 hands, we will have 8 fingers. So why don't I use then 8 to the power 0, 8 to the power 1, 8 to the power 2, 8 to the power 3, and so on. In fact, in place of 8, it can be any number or any digit. So let us see 8. So 1, 8, 64, 5, 1, 2, that means 8 to the power 0, 8 to the power 1, etc. And if I write a number 3, 1, using 8 as my what I call base value, in the earlier one it is 10, and in the present one it is 8. And they correspond actually to different number system, as you know. The first one is we call decimal number system, and the second one is octal number system, 8 for octal. So what is the value of 3, 1 in this number system? So 3 into 8 because it is in the cope or compartment of 8, and then 1 into 1, so it is again 25. So now you can understand probably that what I mean by the puzzle is 31 in or 3, 1 in octal is equal to 2, 5 in decimal system. So they are equal. So the puzzle is all about the number system. Now the question is there can be any other base. For example, NB, n a number represented in base B, which is equal to 2, binary. We call it binary. Then you see one more thing, that in decimal system the number of digits we use is actually again 10. And they are 0 through 9. Similarly, in octal system, again the number of digits we use is 8, starting from 0 through 8. So by same logic, in binary number system, the number of digits we use is 2, and they are 0 and 1. So that is all about the binary number system. But the question is why this is so important in computer discussion. Because the computer hardware, it uses only and only the binary system, 0 and 1. That means if I want to write say 255, 255, then I can write by writing 7 ones, 1 1 1 1 1 1 1. and that represents 255 by the same calculation as I have shown. So the problem is that for a 3-digit number, which is a 3-digit number in decimal number system 255, we need 7 ones, right? 7 ones, 7 or 8 maybe, 8 ones. So a large number of digits are required to represent a number, right? Larger number in binary number system. So apparently it starts with some disadvantage. It requires more memory to represent the number. But for a computer, in today's computer particularly, space is not a problem. So it's not a big problem. Then what is the advantage? And that's the whole thing is advantage because of the technical, the hardware working, functioning process. It works in binary mode. That means every cell, the chip, they work in the binary mode means either electric, it's a circuit, so either electricity is through it or not. So that means the switch is on or off. So you can best represent by 0 and 1. So that's why we use a binary number system in computer architecture. So now I am going to slide number 8. I am going to give you a quick classification of language. Other than high level and low level language, as I have already mentioned, and there are another more classification scheme. By that we say that there are 2 types of languages. One is interpreted language and another is compiled language. Interpreted example is Python, where this compiled language is Fortran or C or C++, etc. The basic difference is that in case of interpreted language, the interpreter interprets the source code during runtime. So one line after another line, it is being interpreted, but during runtime. So it is being interpreted as many times as you run the program. But in case of compiled language, that is Fortran or C, once for all the compilation is done, and then whatever number you run the program, it doesn't compile it any further, unless of course you change the program, then it again recompiles. So that is the main difference. And as a matter of fact, and as a result, in case of interactive application, the first one, Python kind of language, is more useful. But in case of large scale computing, number crunching, then it is of course Fortran and C kind of languages are more convenient. Partly because line by line and runtime interpretation, the compilation itself is a slow process in case of first category, whereas in the Fortran or C case, the comparison is faster. So that is basically the difference between Python and Fortran. And then next slide, Fortran history quickly. Fortran history, actually before Fortran was developed, people used to write in assembly language any program, and to say the least, it was very tedious. And 1957 first time Fortran was developed by IBM for scientific applications, and it's the first widely used high level computer language. So it has some heritage, the first one. And then of course it evolved, more and more added modern features were there, and the first one is Fortran 66, then we got Fortran 77, then Fortran 90, 95, 2003 and so on. But at this level we don't bother to learn higher or advanced level of Fortran. Fortran 77 is enough, good enough for us. Well, now we are ready to learn about the language itself, Fortran. As you know, for any language, it requires a Varna Porichoy, alphabets. So here also for Fortran we have an alphabet. What are the alphabets? Awa, Koko, digits 0 to 9, all the 10 digits are there, valid in the Fortran grammar. Alphabetic characters, all A to Z, 626 alphabets, letters, and then some special symbols. So for example, plus, minus, star means multiplication sign, forward slash, that means division sign, decimal point or full stop you can say, comma is valid, inverted quote sign equal to sign dollar parenthesis, and the last one is blank space B. So these are the valid characters. Your keyboard contains so many other characters as well, but these are valid. These are only the valid characters in Fortran. One more thing, the uppercase lowercase problem is not here. The language is not case sensitive, and the blank. If you want to write 4 star I blank plus blank 6 star J, it's better, looking better. You can write because it ignores the blanks. Even consecutive blanks are also ignored by the compiler. So I am going to slide number 11. Now I would like to show you programming. The first example of a program. In fact, I have not given any points on writing a program, but still I am only elaborating the basic things, and in that basic things, one is there which we call name and value. So what does it mean? Suppose the problem is to write a program to compute the sum and the product of the numbers I equal to 24, j equal to 3, and k equal to 7. So I am trying to write a program for this simple problem. Now, first of all, this is part of our grammar, that how I will write the, in what fashion I will write. Is there any restriction? The first one is, there is a distribution of column number or cell number, you can say. So it goes like 1 up to 72, and comment C on column 1. What I mean, the line like this. So if you put C in or under 1, that means in the first column C is there, then in that line you can write anything you like without bothering about the grammar. You can write hiji biji beach, whatever you like, and this is a part of your good documentation. Then the very first line you are declaring that what the program is all about, so that after 2 or 3 months, if you just relook at the program, you can easily understand, okay, I have written this program for this. So it's a documentation part, and it's not being compiled by the compiler. So you can write anything you like. Now I equals to 24. So what does it mean? The left hand side I, it's a name of an address, right? Thikana, jar naam hocche I, and on the right 24, that is 24, it is the value. So name and value. I am assigning the value 24 to the name I. That's all. So similarly, j equals to 3 and k equals to 7. Now I want to add this 3. So I am giving a new location name or address. I am calling it L sum, and it actually contains the sum of I, j and k. So I plus j plus k. On the right side they are occurring, that means they are the values, right? On the right side, that means they are the values of I, j and k. And on the left, L sum means it's a variable name. So that means the right hand side total sum value is assigned to the variable name L sum. Now you may ask that I am doing a summation, so I could have given the name only sum. Why L sum? That I am explaining later on. And similarly, you need the product, so you write L prod, I star j star k, and then write star comma star quote I, j, k sum and product equal to unquote, and then write I, j, k, L sum, L prod. So there is a difference between these two write statements, and the first one you follow some quote unquote is there. By the by, this quote and unquote, the same key is being used for this quote and unquote, which is usually not the case in our English language. They are inverted forward and backward kind of thing, but here or the same key is used, single quote. Okay. So within quote, whatever you write, it gives a echo like thing, that again in this case you can write whatever you like in this without bothering about the grammar. It will just give you the echo of that line. When I will run the program, you can see, and then write star comma star I, L, j, k, etc. In this case, the quote and unquotes are not there. That means they are not echo. This time the computer searches for the values of variable name I, j, k, etc. and it will report, it will write, or it will print the values I, j, k, not the name. But in the earlier case, earlier write statement, you will see that on the screen it is writing I, J, K, sum and product as such, echo. Okay, pause, stop and end. The output would look like this: I, J, K, sum and product. That's line that is echoed, and next line you will get the values I told, that's 2437, the sum 34 and the product 504. Here it will be made clear in the next session probably. I am just mentioning that in write statement a star comma star, double star is there. What do they mean? Actually I can write in another fashion, as you see, write 6 comma 10, but instead of that, if star comma star is there, that means that you are using two default option given by the computer. You are not mentioning anything else of your own, you are using just the default, and that is 6 and 10. If you write, then you are mentioning that okay computer, you follow my instruction, you don't write in your own way or own fashion. So what the first star or 6 means? The first star means that you ask your computer to write, but write to where? কোথায় লিখছে? Is it on the screen? Is it in a separate file that you have opened in the program, etc. So by default means it is writing on the screen only. But if you write 6, then that means there is a file whose number is, level number is 6, and whatever you want to write here, it would write in that file, not on the screen. So that makes the difference. And what about the second star? Here it is 10. If I replace the second star by 10, that means if it is star, then by default how, in what fashion it will write the values I, J, K, L sum and prod, etc. That means whether they will be written having some gap between them, how much gap is there between the two results I, J or J, K, etc. So that is by default, but you may be interested to have your own design of your output fashion. So you may need that there should be 2 or 3 space between I and J, and 3 and 4 between J and K, and then lot of space between K and L sum, that you can design in your own way. But in by default case, it is the uniformly regular interval would be there between any two results. Okay, so that's all about, but that will be more clear after maybe second or third session. So now I am going to the second 12, slide number 12. This is an example of another program, making decisions. I am highlighting that making decisions. The problem is like this: to print the odd positive integers from 1 through 11 and their squares. Very simple problem. It's not logically not demanding. Again I am marking 1, 2, 3, 4 up to 72. Well, in the previous problem and in this program also, I have mentioned that if you write C under column 1, then it behaves like a comment and the line is not being compiled by the compiler. But I have not mentioned what the role of other column numbers 2, 3 up to 72. So let me mention that other than the first column, which is reserved for comment statement C, then 2 to 5, 2, 3, 4, 5, these 4 place, these are booked or reserved for statement number. So statement number 4 digit maximum. That means you can use a maximum of 9999. A statement number, level number 9999, and the minimum you can write is just 1. Anywhere between in the place of 2, 3, 4, 5 column, anywhere you just write 1, and then it is a statement number 1. So that is the thing. But what does it mean, statement number? What is its role? How we use that? That will be clear in this program. Now comes the column number 6. 6th column is called continuation column, and I am coming later to this 6th column. Then start from 7 to 72. All these columns are booked for your statements. That means the real program is there. The algebraic arithmetic expressions, the variable names, etc., etc. Everything whatever you like in your program, you have to write from 7 to 72. But suppose that you want to write even longer expression, a single line expression, but even longer, which is not being accommodated within 72 columns, then what we will do? What we will do, you can continue, in the following line, in the column 6, you just put some number and then you write whatever the continuation from 7 to again onwards. So then if you write something in column 6, that means it indicates that it is a continuation of the previous line. That's all. But it's not a good practice to write so long a statement or expression. So it is often not used. Right. So here again I am putting a C in the first column to give my declaration that it is an odd integers in the squares. Then I put n equals to 1. First odd integer is 1. Then I of course I would like to square it. So n into n is, say, k is the new variable. And then I would like to print it or write it. So I write star comma star n comma k. Then what I will ask for? আমি চাইবো এরপর n টাকে সেকেন্ড ইন্টিজারে চলে যেতে, অড ইন্টিজারে। সো 1 থেকে আমি 3 এ যাব, তখন আমি 2 যোগ করব। সো I will make n equal to n plus 2. And then I will ask for again squaring the new n, that is 3. So should I write again the next line as k equal to n star n? Yes, in principle I can. That would give you 3 into 3 is 9. The new k is 9. And then again you need to go from 3 to 5. So again you need to write n equal to n plus 2, and again k is n star n. So that means you have to repeat the same statement again and again and again, which is of course a very bad and awkward situation. So that's why I have to make a decision. I have to make a control of the program. I would like to go back to the line where I have put 21. You notice that 20 is in column number 3 and 4. So I mentioned that it is in between 2 to 5, right? So it's okay. Now I would like to go back to 21 statement line after getting the new n. So how I can do that? You see, go to 21. You just forget about the left hand side part. Go to 21. So after getting n equals to n plus 2, I instruct my computer to go back to statement number 21, and by that line it calculates the square of new n, and then again write, and then again comes to n equal to n plus 2, because the compiler goes from up downwards down the column. So n equal to n plus 2 again it does, and again go back to 21 and so on. But then the question is how long, for how many times it will go back. If the left hand side, that is if n less than 12 is not there, then automatically it would go and go and go back, so infinite times. So it is again something very peculiar. So you have to give a check that you have to stop after some time. When to stop? According to my problem here, n should not be greater than 11 as odd integer. That means 13 is not allowed. So n has to be less than 12, right? So if it is less than 12, the answer is yes, then you go to 21. If the answer is no, then you don't go to 21. Then where it will go? It will go to the next following line. So next following line is pause. So your job is done. So it executes first n equal to 1, then n equal to 3, then 5, then 7, then 9, then 11, then 13, but 13 is greater than 12. So it doesn't execute. That means it doesn't go back to 21. It goes to the next line, pause, stop, and end. So that is how logic plays its role. And I can make a decision by simply putting a go to. By the by, LT means less than, so GT, LE, GE, NE, they mean greater than, less than, equal to, greater than, equal to, not equal to. And one more interesting thing is that the output would look like this, and one more interesting thing is here, very interesting, n equals to n plus 2. If you ask any mathematics beginner that what does it mean, he or she will say bogus, simply nonsense, because n equal to n plus 2 means 2 equal to 0, absent. But here this n equal to n plus 2 kind of thing is, you can say, the one of the central strength of computation. It is simply because this equal to sign is not really equality, but it is assignment statement. It involves two actions. First of all, n plus 2, the right hand side, it executes the value of taking n, the current value of n, adding 2 to that current value, and it gets a new value, and that value is assigned to the address variable name n. So n is modified here to a new value. So that is the beauty of this statement. So now I am going to slide number 13. As I have mentioned, that compilation Compilation is basically translating source code written in high level language to a machine level language, and the things are written over there. You can take your time, and it's a simple exercise. You can carry it out from centigrade to Fahrenheit or Fahrenheit to centigrade, the conversion. You can write a simple program for this. Now I'm going quickly through a few syntax errors. Syntax is a beautiful word, but error is not so beautiful. Syntax means grammatical kind of thing. So that means the language has its own grammar, ব্যাকরণ আছে। তো এই ব্যাকরণটা মানতে হবে। কিরকম, মানে হি ইজ গোয়িং বলি আমরা, হি গোজ বলি, হি গো বলি না, কিন্তু আই গো বলি। সো দিস কাইন্ড অফ গ্রামার্স আর দেয়ার ইন দিস ল্যাঙ্গুয়েজ টু। For example, the variables, that means the names, it has types. Basically two types, but actually three types. One is called real type, another is called integer type. It's not like mathematical real and complex, but real and integer. In computation case, real means a value with decimal point. So 5.7 is a real value. 5.7 is a real value. Then what about 5? It can be real, but then in that case it would be 5.0. Value is 5, but it is 5.0 or 5.00. And integer, it doesn't have any decimal point. And the basic difference is that, as far as arithmetic calculation is concerned, in case of integer variables, they are truncated, but in case of real variable, they are not. For example, 3 by 2, it should be 1.5, isn't it? But in integer mode, it is 1, because 3.5 is 1.5, but 0.5 should not be there in integer name. So it's simply 1. So similarly, 2 by 3 is 0.666, but in arithmetic case, in integer case, it is simply 0. But as you see, 3 by 2 is 1.5 in real mode case, and 2 by 3 is 0.666667. You can ask a question that how many 6 should be there? Actually, you can go up to infinity, 66666. Here is a question of rounding up, that at what point you will round it up. This is actually a case of precision, we call it precision. Computer by default uses, we call single precision. That means up to 8 decimal place, it gives you the correct value. Then it round up, okay? And you can extend for your, if you demand more precision, more accuracy in your calculation, then you can make it even double precision, and it goes up to 16 place correct value. So usually you don't need at our level. So that is the difference. And now another one is syntax number 3. Okay, if there are two types of variable, then is there any restriction that how I can name the variable, or I can name in any way I like? No, there is by default there is a restriction. The first one is, you can use of course the alphabets and the digits, but in a fashion that, suppose area 1 or area 2, it's a valid name, but 1 area, 2 area is not a valid. That means the variable can be alphanumeric, but it must start with an alphabet, not a digit. And the second point is that, as far as declaration of the type is concerned, usually any name which starts with either A, B, C up to H, or O, R, S, T up to Z, leaving I, J, K, L, M, N. These 6 letters, if you leave aside, then rest of the alphabets you can use for real variable name. But if a name starts with I, J, K, L, M, N, any one of them, then it is by default an integer variable. Of course, you can change this by default situation by explicit declaration that we will learn later on. For the time being, max, I, J, dim, because they start with M and J, they are of course integer variables. Now I have touched only a few of the syntax, because one by one if I go on telling, then it looks very boring. So better to have a fun kind of thing through learning, and that's why quiz time. So this quiz time is designed in such a way that you go through the quiz and you learn what are the types of errors we usually do, what are the valid, what are the invalid, etc. What are the probable mistakes we often do in writing a program, etc. So I am not elaborating the quiz time in my voice narration. You can go through the quiz. There are some exercises. You can please do that, all those exercises, and you can come back with your answers, with your problem in WhatsApp group anytime. Many people are there in the group, not only me, to help you out. So enjoy the quiz part on your own, and thank you very much for listening. Thank you.